Hello and welcome to another yearly past paper session. Today's paper is an S2 exam. I'm solving November 2361. Let's begin. It says a random variable x has the distribution 410 and 400. Find the probability that the mean of a random sample of 36 values, n is 36, and I'm asking you for the probability of x bar is less than 405. Now I must have the distribution for x bar. X bar then follows a normal distribution which has the same mu, but has a different standard deviation. So it's going to be 400 over 36. Okay, so in that case, uh, I get probability of z less than 405 minus 410 over root of 400 over 36. Okay, that gives me z is less than, I think, 1.5 something. Let's check. Minus 5 divided by 20 over 6. Minus 1.5. Okay. So that becomes 5 minus 1.5, and that becomes 1 minus 5, 1.5 according to the normal distribution rules. Okay, let's open up our formula sheet. Should be here. I will need the normal distribution table repeatedly. So 1.5 gives me 0.9332. Okay, so I can do 0.9332 minus 0.9332. 0.0668. It's the first easy question. Then says question number 2 says in a survey of 300 randomly chosen adults in Rickton, 134 said that they exercised regularly. Um, and this information was used to calculate an alpha percent confidence interval. Okay. And alpha percent confidence interval for the proportion of adults in Rickton who exercise regularly, the upper band of the confidence interval found to be 0.487 correct to three significant figures. So the upper bound is calculated by the proportion in the sample plus z value into root of proportion of sample into q of sample divided by n. So the proportion of the sample was 134 over 400. I don't know the z value. That's what I'm trying to find out, and that will help me come up with an answer for the confidence interval. Okay, what's PS? It's 134 over 400, and QS, not 400, it's 300. Okay, 300, and this gives me 166, 166 over 300. Okay, and then divided by another 300. And that should be equals to 0.487. Okay, shuffling things around will give me a z value. Let's quickly calculate that. 134 divided by 300 into 166 divided by 300 divided by another 300, root of answer, and then 0.487 minus 134 over 300. I'm getting the z value as 1.405. Now the z value is 1.405, so I will find out my confidence interval accordingly. I'm going to say that this is phi of, I will have to do phi of 1.405. Okay, so let's do that first and then we'll see. So phi of 1.405, 1.40 and 5. So 9199 should be my reading of probability, 0.9199. Okay, so what I've read basically is this 0.9199 is the entire probability that I have here. Okay, when I construct a confidence interval, I know that it's on both sides. So what I'm going to do is I'm going to create another boundary here and say that how much is this area? This area should be the same as this area, and then the remaining should give me the confidence interval. So what's 1 minus 0.9199? That's 0.0801. So there should be a 0.0801 here as well. So I'm going to say that the confidence interval is basically 1 minus 2 times 0.0801. Okay, 0.8398. Okay, so it's approximately 84% when I round this off to see significant figures. So alpha confidence interval is basically 84%. Okay. Then the third question looks like it's about a Poisson distribution. So it says a website owner finds that on average his website receives zero point 0.3 minutes hits per minute. He believes that the number of hits per minute follows a Poisson distribution. Assume that the store owner is correct. Find the probability that there will be at least 4 hits. The x is greater than or equals to 4 in a 10-minute period. Okay, so I will have to find the lambda for 10 minutes. The lambda is 0.34 times 1. What is the lambda for time 10? I'm going to say that's 3 hits per minute, 3 hits per 10 minutes. So my lambda is 3. And if I have to calculate at least 4, what I have to do is 1 minus probability of 0, 1, 2, and 3. Okay, so I'm going to write down e power minus lambda, e power minus lambda minus e power minus lambda into lambda power 2 over 2 factorial minus, hope I'm applying the formula correctly. Um, yeah, e power minus lambda into lambda power 4 over 4 factorial, or 3 factorial, lambda power 3 over 3 factorial. Okay, I'm going to use my calculator to do all of this. I know that my calculator has probability function, so I'm going to use that. Um, Poisson CD variable 3, lambda is also 3. I get 1 minus 0.6472. Okay, so what's 1 minus 6.6472? It's 0.3528, which is 0.353 correct to 3 significant figures, and that's the correct answer. This is use a suitable approximating distribution. Okay, so I have to decide what I want to convert this Poisson distribution into to find the probability that there will be fewer than 40 hits during a 3-hour period. So the lambda seems to have changed. It was for 1 minute. The time is now 180 minutes. 3 hours is 180 minutes. What's the new lambda? It's 0.3 into 180, 54. Okay, so I have 54 here. Now I know that lambda is large when lambda is greater than 15. You sort of convert to a Poisson into a normal distribution, but whenever you're doing that, you need to do a continuity correction first. You say that the continuity correction is going to be x is less than 39.5. If you don't remember the rules, please make sure to go back and revise the rules for continuity correction. Okay, what's my mean? My mean is lambda, and my standard deviation variance is also lambda, so that this is what I get. Okay, so 39.5 minus 54 divided by root of 54 gives me probability of z is less than minus 1.973. Okay, so that becomes 1 minus 1.973, 1 minus 5 of 1.973. What's 1.973 from my table? 1.973 0.39758 then. Okay, I am getting 0.0242. That's the correct answer. Then the next part says a friend agrees that the website receives an average of 0.3 minutes hits per minute. However, she notices that the number of hits during the nighttime is usually about twice the number of hits during the daytime, the nighttime. Explain why this fact contradicts the owner's belief that number of hits per minute follows a Poisson distribution. For a Poisson distribution to be valid, the mean should be constant. So the mean is not constant here. It's different in the morning and different in the night. So that is the difference. So you'll just say mean is not constant, lambda is not constant, whatever you want to call it. Okay. Um, then it says specify separate distributions that might be suitable models for the number of hits during the daytime and during the nighttime. Now I'll need separate Poisson distributions, but I'll have to calculate the number of hits per minute for both daytime and nighttime. I know that the number of hits from the daytime is twice that of the nighttime. So if the nighttime was P and daytime is therefore 2P, but what is the other side of the equation? I'm going to say that it was generally zero point 0.3 per minute. Since I've added daytime and nighttime together, I'm going to say that it's zero point 0.3 into 2 right now. Collective daytime and nighttime together should be zero point 0.6 for 2 minutes. Okay. Then I'm going to say that 3P is therefore zero point 0.6 divided by 3. P is therefore zero point 0.2. Okay, P is zero point 0.2 per minute for daytime. This was also per minute, therefore this was also per minute. So therefore this was for 2 minutes. Okay, so I'm going to say that the daytime is a Poisson distribution with 0.4 and the nighttime is a Poisson distribution with 0.2. Okay. Okay, question number 4 says the masses in kilograms of chemicals A and B produced per day by the factory are modeled by this. The income generated by is 2.50 per kilogram for A and 3.25 for B. Find the mean and variance of the daily income generated by chemical A. So income from A is therefore 2.50 times A. So I'm going to say that the mean is going to be 2.50 times 10.3. That should give me what? 2.50 into 10.3, 25.75. And variance is going to be 2.50 squared into 5.76. 36. I think those are the correct numbers. Yeah, those are the correct numbers. Okay. Then that's this is 2 marks, and the probability that in a randomly chosen A, the income generated by chemical A is greater than the income generated by chemical B. So income generated by chemical A follows a normal distribution with what I just found out, 25.75, 86. But I haven't found out income B, so I'm also going to do that first and then go on to the question that is there. It's 3.25 times 11.4. 3.25 times 11.4. That gives us 37.05 and 3.25 square times 9.65. 101.506. Looks like a very large number, but yeah, that is it. Yeah. Okay, so what I want is the probability of income of A to be greater than income of B. But I can't solve on both sides, so I'm going to create a new variable by subtracting this and call that the difference, income of A minus income of B. So difference then follows a normal distribution. with 25.75 minus 37.05, and the variances always get added. Minus 11.3, comma 137.506. So probability of difference greater than 0. So z is greater than 0 minus 11.3. So probability of z greater than 11.3 divided by root of 137.506. I'm getting 0.964 here. Let me check if that is the correct number that I need to get. Yes, I am going to say 1 minus 5.964. What is 0.964? 964. So 8325. 0.1675. Correct to three significant figures, I'm getting 0.168. Moving on to the next one, there's a lot of space. I thought I was running out of space, but there is a lot of space. In the past, the number of inquiries per minute at a customer service desk has been modeled by a random variable with a distribution. This, following a change in the position of the desk, it is expected that the mean number of inquiries per minute will increase. In order to test whether this is the case, the total number of inquiries during a randomly chosen 5-minute period is noted. You should assume that the Poisson distribution is still appropriate, given that the total number of inquiries is 5, so that's the test statistic. Carry out the test at the 2.5% significance level. So I'm going to say that H naught is lambda equals to 0.31. Now you're expecting that this is growing, so lambda is greater than 0.31. So this is basically an upper tail test. What is my test statistic? It's 5. So I'm going to calculate the probability of x greater than or equals to 5. But for a 5-minute period, this lambda is for 1 minute per minute. Okay, per minute. So for 5 minutes, the lambda is going to be 0.31 times 5, which is what? Which is 1.55. Okay, so I want to calculate the probability of greater than or equals to 5. So I'm going to say 1 minus probability of 0, 1, 2, 3, and 4. I'm going to write down my expression. Let's see if there are marks for the expression as well. Yes, there are marks for the expression. So e power minus lambda e power minus e power minus lambda to lambda power 2 over 2 factorial e power minus lambda into lambda power 3 over 3 factorial minus e power minus lambda into lambda power 4 over 4 factorial. Okay, again, I'm going to use my calculator to do this quickly. I know that I have my distribution on my calculator. This is a Poisson CD, reuse variable, and say that I want to calculate for up till 4. So 1 minus 0.97897. 1 minus 0.97897. And I'm getting 0.0210 basically. So is that's 2.1%. Okay, 2.1% is less than my significance level. So I'm going to reject H naught and say that the conclusion is that the number of inquiries has increased. Mean number of inquiries has increased. Okay. Moving on to question number 6. It says a continuous random variable x takes the values from 0 to 6 and has a probability distribution that's symmetrical. So it should be symmetrical at 3. Okay, two values a and b are such that probability of x is between a and b is p. I don't know where a and b are. And but b to 3. So 3 is an important number. So I know that 3 is right in the middle. So that's 13 over 10p, where p is equals to a positive constant. Show that p is less than or equals to 5 over 23. Now, I don't know what the symmetrical looks like, but I can just draw something symmetrical and say that, let's say, this is the probability density function. It's starting from 0 and going to 3. It could have been a different symmetry. It could have been a triangle. I'm just guessing here, not 3, 6 here, and 3 in the middle. Now I know that there's a number b somewhere less than 3, of course. So there's b and there's a somewhere here. Okay. Now this area is small p and this area is 13 over 10p. Okay. So I know for a fact that p plus 13 over 10p should be less than or equals to half. The probability is 0.5, right? So it should be less than or equals to 0.5. So that gives me 23 over 10p is less than or equals to half. P is therefore less than or equals to 10 over 2 into 23. Does that give me my answer? Yes, P is less than or equals to 5 over 23. It's just about drawing it and then seeing the conclusion. This drawing will help me later on as well. It says find the probability that x is between B and 6 minus A. Okay, so let's bring that diagram down again and let's see what the question is asking. Now I'm asking you for the probability of numbers from here, starting here, and stopping at this point, 6 minus a. Okay, this I call this 6 minus a, and it's going to have the same area that it had here. So what was this red area, that red question mark? I can say that this is zero point 0.5 minus p minus 13 over 10p. Okay, let's see what that comes out as. 0.5 minus 23 over 10p. Okay, I can say zero point 0.5 minus 2.3p. Okay, so this red area is also zero point 0.5 minus 2.3p. Now, what area do I want? I want the entire area from, what probability do I want? I want the probability from B to 6 minus A. Okay. Hmm, B to 6 minus A. So either I could subtract a lot of things, or I could just say that it's B to 3 is 13 over 10p, and then from 3 to 6 minus A is going to be zero point 0.5 minus this probability that I just calculated. So it's going to come out as 13 over 10p plus 2.3p. So 1.3 plus 2.3 gives me 3.6p. So that should be the correct answer. Yeah, 3.6p is the right answer. I could have done it in lots of ways. I could have said that this area will basically be equal to this area. So if this is 2.3p, then this should be, just added together. Okay, or something like that. I will have to do some calculations here. I don't, it's 3. Oh, it's wanted from B to A and B to that. So I will have to add that as well. Okay, so lots of ways of, sort of calculating this. As long as you understand the diagram, that should be it. It is now given that the probability density function of x is f, where this and this, given that b equals to 2. So now I have from A to 2, the probability is 5 over 27. And from uh, 2 to 3, 2 to 3. The probability is 13 over 10 times 5 over 27, if that is what I'm looking at. Okay, but I think only this would work. It's just about finding the area of A, finding the value of A. So I'm going to say that I have to integrate from A to 2, and I will have to integrate this function, 5 over 27. Okay, so I'm pulling 1 over 36 out, and I have 6x minus x squared dx from A to 2 equals to 5 over 27. I can move 36 to the other side as well, and I'm going to do that in this step that I have. Twenty over 3. 6 times 2 square, sorry, 3, well, that's 3. It's easier to write down. 3 times 2 square minus 2 cube over 3 minus 3 times a square minus a cube over 3. So 12 minus 8 over 3 minus 3a squared plus a cube over 3. Let's first get this addition subtraction out of the way. 12 minus 8 over 3 minus 20 over 3. So I'm getting 8 over 3 here, and I have 3a squared minus a cube over 3. So I can pull out an a squared. Um, looks something complicated. Let's check if we've done everything right. Hmm, let's check. Yeah, everything seems fine so far. Let's see if this is actually a cubic equation. 3, 3 cancels out. So a cube minus 9a squared plus 8 equals to 0. Okay, so this leads us to a cubic equation that needs to be solved for A. I hope that's the correct cubic equation that I'm solving. I will first need to figure out the first factor. I'm going to use my calculator to do that. I will solve a polynomial and tell you that I have 1, minus 9, 0, and 8. So I'm getting one whole number as a factor. Uh, I have a equals to 1 as a factor. Okay, so I'm going to say that I first do trial and error and sort of show you the first factor that's working out. 0 equals to 0. Then I use a equals to 1 to factorize this expression. How do I factorize this expression? I can use long division, I can use other methods and come up with a number. So I think I'm going to do the synthetic division. I find that the easiest to do. Okay, so I'm going to put out 1 here, 1 minus 9, 0, and 8. So 1 travels down as it is, then it goes up with 1. If you don't know this, it's best to learn it. Even if you don't want to, then that's absolutely fine. This gives me a square, a, and constant. So I have a minus 1 as one factor, and then a square minus 8a minus 8 as the other factor. Okay, then I have either a minus 1 equals to 0 or a square minus 8a minus 8 equals to 0. Now a equals to 1 is certainly an answer, but let's see if that works. Find the value of a. Okay, but I will have to check the other numbers. A equals to 1 is sort of working, but I will still have to check if this works. Plus minus b square, which is why there are 5 marks for this question. So let's do that on a calculator. Gives me 8.89. That seems unrealistic, not possible, because it has to be less than 6. And the other one is minus 0.898. Again, not possible, because negative numbers are not part of this range. So a equals to 1 is the final answer, but I had to make sure that the other two are rejected. Okay. Moving on to the last question, it says a biologist wishes to test whether the mean concentration is mu is suitable in units of a certain pollutant in a river is below the perimeter level of zero point 0.5. She measures the concentration of X of the pollutant at 50 randomly chosen locations in the river. Okay. The results summarized. Carrier to test at the 5% significance level of the hypothesis test. Mu is 0.5 against H1. It's less. So this is a lower tail test. I'm going to draw my rejection region. What is my significance level? My significance level is 5%. So I'm going to read 95% from my table. 95% from my table is, I need to keep doing this where I lose the table. 95% is 1.645. So this should be minus 1.645. Then I'm going to calculate the z-value of my test statistic. What is my test statistic? It's missing in the question right now. I have some data on it. I don't have x bar. Can I calculate x bar? Yes, I can do that. 23 divided by 50. Okay, that gives me 0.46. Okay, I also don't have the sigma square, which I will need for calculating the z-value, which is 0.46 minus the existing mu divided by sigma over root n. But I don't have all of that, so I'm going to calculate sigma square, but I notice that this is a sample, so I will also have to unbias it. I'm going to say that 50 over 49 multiplied by 13.02, sum of x squared divided by 50 minus the mean square. See if I'm doing it correctly. If I am doing that correctly, then I should get the correct answers. 0.46 squared, 50 divided by 49. This means sigma squared as 61 over 1225. What is that in decimals? Reasonable decimal. No, it's a lot of rounding off. So I'm just going to use that and say that 1225 divided by n sigma, so root divided by n, and let's see if I can get a better answer from there. Okay, so I have then 0.46 minus zero point 0.5 over answer divided by root n. Let's see if that is the correct number. I think I've made a calculation mistake somewhere. 61 over 1225. Okay, I didn't root that, I think. So that created a problem. Let me just write that again. Minus 1.268. Is this in the rejection region? No, this is not in the rejection region, not in the rejection region. Fail to reject H naught. Fail to reject H naught and say that not enough evidence that mean concentration has changed. Has changed. Okay. Has is less than 0.0. It's less than 0.5 because it's a one-sided test. A change would mean it's a two-sided test. Okay. Later, a similar hypothesis carried out at the 5% significant level using another sample of size 50 and the same hypothesis as before. We should assume that the standard deviation is unchanged. So sigma square came out as 61 over 1225. Okay, the sample size is again 50. This is given that in fact the value of mu is, there's a new mu 0.4. Find the probability of a type 2 error. So what's for type 2 error? Type 2 error is the probability of acceptance region using new mu. Okay, so do I have the acceptance region? No, I did not convert this into an acceptance region. So first I'll have to do that for the whole question. I'm going to say that 1 minus 1.645 x bar minus 0.5 over 61, 1225 over 50 root n. Okay, so I am first going back to the previous question and converting my rejection region that I got from my previous calculations. So 61 divided by 1225 over 50 plus zero point 0.5. So x bar comes out as 0.448. So my rejection region was x bar is less than 0.448. So my acceptance region should be what? X bar is greater than 0.448. Then can I calculate the probability of this? Okay, just to verify that I'm doing this correctly. 0.448, yeah. So probability of z greater than 0.448 minus the new mu. What's the new mu? Zero point 0.4 divided by 61, 1225, and 50. Let's see if we get that correct. Z is greater than, I am getting 0.448 minus zero point 0.4 divided by, or cos divided by, um, getting 1.521. Yeah, so 1 minus 5 of 1.521. Okay, so 1.521 from my table, 9358. 0.0642. Okay, I wrote that in a fraction. I was about to write that in a fraction, so the calculation seemed very odd. This is the end of the first variant. I will see you with the next variant in the next video. Please make sure to like and subscribe if you're watching this.